Hello all. In the previous video, we have talked about the feasibility study phase, right? And then we talked about what could be done in the feasibility study. So we talked about the technical feasibility, commercial viability, and benefits to the company, right? Now we will go into each of these in detail and what are the things that could be part of this. So in the technical feasibility, what we are going to do is we are going to do the brainstorming of the requirements, the given requirements with the entire team, where all the relevant stakeholders are involved. What are all the design teams that are involved? What are all the managers that are going to involve in this? All the relevant teams will be involved, and we are going to brainstorm around the requirements at a very high level. This is not in technical depth, definitely. And then at one point, we are going to check what are all the high level components that are needed and whether they are available or not. So that is very, very important. And then perform a SWOT analysis of the project team, basically, to determine what is needed for the project from the technical perspective. This is not from the company perspective. So SWOT is strengths, weaknesses, opportunities, threats, right? So this we are going to perform from the um, team perspective. And then if we move to the commercial viability, we are going to check whether the particular product is going to land in profits or losses. That's as simple to put it. Now, in that case, what we are going to do is we are going to see how much demand is there for that particular product in the market. We are going to do a market study. Initially, the marketing team would have come, but again, to calculate from the commercial viability, we are going to further dig deeper, and then we are going to prepare a high level BOM, bill of materials, and then calculate the approximate costing of the board, and we are going to compare this cost with the competitors. That is very important, because if we make a board for $5, and if you want to sell it for $10, for example, and if the customer is selling the product at $5, then there is no use to bring this in the market, right? Everyone goes to our competitor product itself. So very, very important. And then how much quantity need to be built, and what is the investment, and what is the ROI. So these all will be calculated to see whether this project can be taken forwarded or not. And then finally, what are the benefits to the company and what are the drawbacks if we take this project. So again, a SWOT analysis will be done um, from the entire company perspective, and that's where we are going to get a feasibility study report, which could be in a simple Word document and passed on to the marketing team, which has given these requirements. Very important report, because this is going to make or break the project. So whether to move forward or whether to drop the idea of the marketing team will be done here itself. So now, one important point is, as we are going to talk more about the technical terms here, so let us see how the high level analysis, like we are talking about a WM1 project, right? Let us see how the WM1 project requirements at a very high level can be met or not. We have talked about this project requirement sheet, right? And then we got these high level requirements from the marketing team, right? So now we are going to just do a very high level feasibility study or see whether these requirements can be met or not. So for this, we can just prepare a checklist kind of thing, and then the design team can sit together and see if these requirements can be met or not. Like example, design and develop microcontroller board. Definitely, this can be done. There's no issue. Okay. So rather than ticking it, what we'll do is we'll just keep it open. So this means it can be achieved. Onboard peripherals, LED, button, two relays is definitely achievable because you need one GPIO for LED, one GPIO for button, and two controls for relays. So easily achievable. And then you wanted the requirements were like to have UART, SPI, I2C, right? Definitely these are there in the Arduino chipset, right? So we are going to make a Arduino IDE compatible board, and we are going to use the 80 mega chipset. So that means UART, SPI, I2C are present and they can be used. And we wanted PWM analog interfaces, which is always possible with the 80 mega chipset. And GPIO pins extended to a header for future usage. This can be done. Whatever the unused pins are there, we can expand out. And also, if required, we can branch out the existing pins to a header, and then provision to connect 16 cross to alphanumeric LCD. So if you, this is a typical requirement. Now for this particular requirement, right, so we almost need four data pins, four control pins, right, and then the backlight control, all this. So having that many pins, four control pins, or in fact actually eight are required, so we can use it as a four. So in this case, what we can do is we can go back to them and suggest I2C based LCD here. Like it will be a 16 cross 2. We can interface PCF 8744 kind of I2C expansion boards to handle this. So that could be one change. We can go back to the marketing team and tell them. And anyway, it's a design implementation. So as long as 16 cross to alphanumeric LCD is implemented, it should not halt the project. And then must have wireless capability. So BLE, okay, you can handle with UART. Wi-Fi can also be handled. Yes, 3G can also be handled. So these will be a separate modules on the board with serial interfaces requirement. So this is possible. Must have GPS option. Again, this is a serial interface. So this one requirement, like you might need to have a 4 UART interfaces which can be handled in the design. Okay, so not reading all of them at a time, or there can be some arrangement that can be made in the design. So it's not technically difficult. And then onboard sensors, temperature, humidity, accelerometer, all these will have I2C interface, so definitely possible. And then onboard level translator circuit, yeah, this can be used. So what we'll do is these wireless things we will mark in a different color, okay, and we will let them know that these need to be further analyzed, but at this point it can be achieved. And then you need an onboard motor control circuit. Yes, definitely. Onboard debugger slash ICSP, yes, it can be done. Board must be USB powered or power jack option is required, it can be done. And you want to do a power monitoring, voltage and control, current monitoring, yes, it can be done. It should be low cost. So this is again a very tentative statement from the initial analysis perspective. What do you mean by low cost? So we might have to go back to the marketing team or the higher management and tell what actually means low cost, so that when we talked previously, right, we will do a high level costing BOM, and we are going to present that cost to them, and then we are going to get their opinion whether it is achieving their cost target or not. So low cost is a very open statement. So we need further references of what competitors we are considering and what is our cost target. And small form factor. Again, this is another open statement. So what is the reference for us? If Arduino, then considering that these many interfaces are added, it might be very typical to have this form factor, and then low power consumption. This is one more open statement. Again, this cannot be achieved easily, right? So this three are very typical statements where we need further review, or at least some um, figures to consider, such that we can do a feasibility in the background and come back and say, yeah, we can meet or we cannot meet, right? So these three, along with the wireless interfaces, are the typical requirements which need further study. Arduino IDE compatible, definitely, if you are using 80 mega chip, and competitive benchmarking Arduino Uno. So considering that we know about Arduino Uno, and if we have this product, definitely we will have a higher edge, because we are going to build a wireless microcontroller board, whereas Arduino Uno is just a simple microcontroller board. So if we benchmark from the specifications perspective, we are definitely going to have that edge, and board must be ROHS compliant. So this will be taken care from the components perspective. Yes, it is possible. Boards must have test point for access during validation, and 50% test coverage is required. Yeah, this is also possible. Um, and we will, as we evolve in the design, we are going to list down the critical voltage rails or the signals which need to be probed, and then we are going to come up with the percentage coverage. So it might be little lesser than, but the actual statement here is all the critical cases will be covered. Okay, now this is how we make the we do a analysis at the design level. So while we talked just at a very high level, okay, we will be actually doing each and every step in a more detail. Okay, and then what we are going to come up, as we mentioned, is like a feasibility report of the entire project, and present it to the management. So that's how the feasibility study goes. Now, once this feasibility study is done, and we say it is good or whatever, we will talk about the next steps in the further videos. Thank you.